Hey guys, this is Manak, your civil bro. So this is the part 5 of So You Want to Make a Building Structural Drawing. So you see the entire 1 to 4 episodes was designed in such a way that when I got one project, and then we kind of decided that we'll make some parts of the video. Most of the actually the first 4 parts was recorded in a single day, starting from the so 2 days actually, starting from understanding the requirements of the building and what are the things which we need to assume and what are the initial data which is available to us, and then the column positioning and marking the coordinates, because the planning was done by another architect. So, and there was some challenges also in column positioning, because most architects, they do not match by overlapping the plan. When I design the plan, or most civil engineers make a plan, they, or even experienced architects, when they make the plan, they overlap the plan and this and see where the column positions are to be, where the beam locations are to be. So that thing was a challenge, and then we designed in Staad, and then detailed in RCDC. After that, also some changes were made. And the final drawing I'll show you, because the final drawing is the presentation, which many of you do not take into account after designing. You leave, but final all these steps, if I would have recorded, then it would have taken a lot of time to complete it. So that's why I didn't record step by step. But obviously, if you want personal training, professional training, you can mail me, and you can work on 1 or 2 projects, the entire part, including the CAD part. And if you want to learn from YouTube also, you can learn. Take a little bit more time if you have patience, and then you can learn. Okay, so the first part which I presented was the footing layout and schedule. So because and practically this is a residential building, and many places you will not find printers of A4 sheets. So this is a 1:175 scale, and this, and in this sheet is an A4 sheet. All the settings are done accordingly. So you can see the number of footings here, and footing sizes I have divided into 3 sizes here. Footing depths of 450, maximum footing depth is 525, and we have reinforcement on the top and the bottom. So top and the bottom reinforcement. On the top there is nominal reinforcement, the bottom also the same reinforcement. So obviously software it didn't come like this, but the idea is, when since I have also worked at a site, so what are the things which will be easier for the mason, for the site engineer to execute, to cut the rebars, and also the more symmetry you have in your drawing, the more easier it is to execute. So that's why symmetrical reinforcement management has been given. And then here we have we have some general notes here, and the bar, and the this covers which are to be provided, development length 50D, and building design for G+1. If you go beyond this, then this design won't work. You need higher sections of columns, and foundation also. So that's what is written in the general notes. And this is the section. You can see 1.5 is depth from the ground level, okay, natural ground level, and the foundation, and 850 is the plinth height, okay. So you can see this, and so we have a tie beam here, and between the tie beam and the plinth beam there will be brickwork. So tie beam section is also given here. And tie beam actually helps, instead of a brick pillar, I prefer tie beam, because it helps, you don't have to do the extra digging, and it helps, it's better, lesser bricks are required. So if this is not your suitable thing, then you can also go for the brick foundation instead of the tie beam. Or if you give the tie beam, then only the brickwork within plinth level and foundation is required. So this is the case here. And you can see the top reinforcement and the bottom reinforcement arrangement is given here. So anyway, you can understand the arrangement of the top rebars and the bottom rebars, and they are same. So there is no confusion of this way and that way. So there is no doubt in that. And the other columns and plan and elevation are also given for the other 3 footings. Then we come on the main thing, the column layout. So I have a lot to discuss in this column layout, actually, because the first thing I will tell, which civil engineers who are not experienced, who are experienced side, they will immediately understand this minor things by just by seeing the plan. Who have executed a foundation layout or experienced site engineers, they will easily understand. But for new people, that is, even if you have a PhD degree, if you not executed, then you won't know these small things. So this C1 size 300. So I will give a grid here, and so the grid is obviously in the middle. Okay, and you see 150. So 150 means, and this is not actually in the middle. 150 from this side. Okay, so if I had another column also, like for this is 175 in left side. So why I've noted 175 only? You can see if you just check in the beam position, that beam, this is the third one, right? This is the third one, second one. So beam is in the left, beam is left flush. Okay, for these two columns, beam is left flush, right? Left flush means aligned to the left side. That's why 175 to the left. So that's why this also, you can also understand the beam positions also from this diagram, from these this denotation. This is not in the middle, so that's why it's mentioned, and then the beam position also. So like this position is 150, so meaning that the beam is flushed at the top portion, not at the bottom portion. You just see the beam plan. So beam is flushed to the top portion, and obviously the beam here, is the same size. So it's not, yeah, this here you can see it is aligned to the top portion, not the bottom portion. This column is larger size, these two. So you can see that here. So that's why it is given here, this flush positions. All the positions which do not have flush means, like C1, this column, for example, it is vertically also at center, longitudinally, horizontal and vertical, both there at center. So this is horizontally at center, but vertically is not a center. So this is given 150. Again, this 150 is given in this side. You can see exactly my beam location. It's flush at this side, right side. So here, these are small, minute things which come with experience. But if you follow it from here, it's good. Or if you have trained under a person who is an experienced structural engineer or structural draftsman, so you can just easily know these small things. So these are the things. Column size was 300, and kept it minimum as simple as possible. 3 types of columns, and the rebars you can see, and we have 8 rebars in all the 3 sizes which you provided. So 420, 416 in the C1, and 816, and you can see 816 also in the third size of the columns as well. And in the rebar, you have this zones here, near the ends, and there is less reinforcement near the at the top, or sorry, at the central region. There tie spacing is more. So that is kind of covered. So that region is actually L by 4. This is 3000, the L by 3000 by 4, 3000 by 4. There will be 125 spacing of the ties, and in the middle there can be more spacing, that is 175 spacing. So this is it, and that could have also been mentioned. Okay, this is the plinth beam layout. Already you have seen that the flush locations you can find out along which the direction the columns are flush. And you can also find out the reinforcement here. So in the plinth beam, we try to keep it simple again, using the word simple, 320, 320, 320, 320. So no extra bars for the plinth beam, and you have the plinth beam sections. So here in the plinth beam sections, you can see these markings here, 1000, 1800 from here, 1000 from here. So this is the to denote this shear reinforcement. So this is at the support, and this is at the center. So at the support, we have this is not mentioned here, but this roof beam also, it is it should be, this is actually support. At support, it is your this 1000, which is marking. This is ST1. So at this near the supports, this is the up to 1000, from suppose up to this span, the spacing will be 125, and in the remaining portion there will be 150. Similarly, at this all these locations, this will be 125, and the remaining there will be 150. So this is the detail which is given, detailed sections, and these longitudinal sections and these sections. So these are given here, and you can find the similar things in the roof beam layout as well. You can see the roof beam size 300, 500, 300, 500, and 250, 500. So all these were safe sizes. And similarly, you can find the sections here. Suppose, let's see a section here. Now, this is the section of beam B1. B1 size is 300 into 500. So 300 to 500 section you find. You cut a section at 1, section at 2. So first of all, at 1000, this is extra top bar length. from this side and have extra top bar length from this side, 1000. So in this 1000, there will be the extra bars of B1. Extra bars are 316, whether at top and bottom. So again, to keep it symmetrical, same extra bars at top and bottom are provided. So extra bars at top and bottom. At the one section, there will be only extra bars at top. So extra bars at top are there. And in the two section only, there will be extra bars at bottom. You can see the extra bars at the bottom. Okay. So like this, you can find out this rebar arrangement here, and you can similarly find the rebar arrangement for B2. In B2 there is 216 extra bar instead of this 316. So you can find this sections 3 and sections 4. So these things you can find, and you can find that whenever the beam size is 450 mm or more, you have the side face reinforcement, and the side face reinforcement is placed exactly in the middle. If you have two layers, then it in two layers, otherwise it's placed at the middle. So 212 side reinforcement for the beam of depth 500, and 350 is breadth, and in this B1 we have one pair, that is 10 mm reinforcement, which is placed at the center. And all the secondary beams, you can see there is B3 316 316 215 to 350 normal arrangement has been given. So this is the rebar arrangement here, and this is for the slabs. So for the slab in this portion, there is double mesh for the cantilever portion we provided, and the rest portion we have provided the crank bars. And A and B, if you just see here, A and B both have 10 spacing of 200. Effectively, it will be 100 because we'll place the crank alternatively. So this one on this side and on this side. So exactly this is just zoom in and go along a span. You can see exactly the kind of arrangement which has been exactly the length has been given. So the person doesn't have to calculate L by 3 L and this thing's length. So exact length has been given. It will be easier for the mason to execute, like we have in project. And also we have in code different lengths along continuous and discontinuous end, but I've taken the maximum one and provided because again it is easier for execution and also simpler. So that's why it is given this crank bar arrangement, and distribution bar obviously will be provided wherever required. So this is the case, and this is the section of the staircase. Rebars, 10 mm rebars have been provided at staircase. The chaja, wherever we have window, we'll have chaja and extension protect from the rains, and lintel beam details is there. So this is a very simple arrangement yet detailed arrangement which we have gone for. Okay, for presenting the results of the building. So this is it, and this is it for the drawings and all. So the precise part in AutoCAD, if you do, if I have recorded, that would take a very long time. So that's why I have not done. But if you're interested to learn, this kind of project, because it involves taking time, you can mail me, or else you can also, or else if you know basic AutoCAD portion also, you can do it. But important thing is to, just keep exploring these things. And if in any particular topic you want a video, feel free to comment, and I'll make sure I make a video on that. And also don't forget to like, because it helps to grow in the YouTube algorithm. Thank you, bye bye, and keep learning. Bye.